The weekly mortgage payments of 12 people are as follows. We want to calculate the mean and median for the data set. So for the median, we really need them in order. The smallest is a 288, and then nothing else in the 200s, but in the 300s we have a 347 and a 395, and in the 400s we've got a 423, a 481, a 487 and a 492. In the 500s we've got 511 and 567. Then we've got 607, 661 and finally a 1124. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. 12 plus 1 divided by 2 is 6.5. So between the 6th and 7th pieces of data, 1, 2, 3, 4, 5, 6, halfway between 487 and 492. So we can find that by averaging those. So we need to do 487 add 492, and then we can just divide that result by 2, and it's 489.5. So the median is 489.5. Now, what else have we got to do? The mean, so we need to add them all up and divide by the number of pieces of data. We know the number of pieces of data was 12. So what have we got? We've got 288 and 347 and 395 and 423 and 481 and 487, 492, 511, and 567, 607, 661, and finally 1124. And that gives us 531. So these are dollars, aren't they? So it's 531.92. This is dollars as well over here. Compare the difference between the median and mean values and comment on it. So the difference between the two is going to be that one take away that one. So we've got a difference of $42 and 42 cents. And it's quite a big difference. Two measures of the centre differing by $42 in this sort of range of values. So that's all I'm going to say for now, and there's more things to comment on further on. We want to identify any outliers present. So we need the quartiles. Now if we look at this list, 1, 2, 3, 4, 5, 6, we know that we need to be here for the lower quartile. 1, 2, 3, we need to be in this gap for the upper quartile, so halfway between these values here. So we've got 395 and 423, and then we'll divide that by 2, so 409. So the lower quartile, let's get the eraser. The lower quartile is 409, and the upper quartile is between these two. So 567 add 607, and we'll divide that by 2, gives us 587. So therefore the interquartile range is 587, take away 409, gives us 178. Of course that's still. So if we do lower quartile, take away 1.5 times the interquartile range, that is going to be 409 take away 1.5 times 178. So 409 take away 1.5 times 178 gives me 142. And we don't have anything below 142, so there's no outliers at that end. Upper quartile, add 1.5 times IQR. Well, the upper quartile we said was at 587, and then we'll add 1.5 times 178. So 587 add 1.5 multiplied by 178 gives us $854. So 854, the 1124 is an outlier. Which measure of centre is appropriate to use and why? Well, for this sort of data, we'd probably say the median, and the outlier unduly affects the mean, especially since the outlier is so far above this 854 value. Take out the outlier and recalculate the median and mean. So this one we've circled, we take out. We've now got 11 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's take out these marks. If we do 11 plus 1 divided by 2, that's 6. So 1, 2, 3, 4, 5, 6. The median is now 487. And then for the mean, I think we can just go back on the calculator and find where we did the mean before. Here it is. And what do we need to do here? Well, we need to reduce this to 11 because we've now only got 11 pieces of data. And we need to take out the 1124. And we need to go back up and find that, and that's 478.09. So the mean was 478.09. Using your answers to A and E, discuss the effect of ignoring the outlier. Well, median and mean are much closer. But does that necessarily mean that we should ignore the outlier? Well, the outlier may well have been a genuine piece of data. So you might want to leave it in because it's a genuine piece of data. On the other hand, it just depends what analysis you're doing, and so many of these questions are quite woolly in statistics. It's hard to say exactly what an examiner would be looking for in any particular situation, but certainly we can see a big discrepancy in the mean and median here and a much smaller one here, so that's what I'd go with.